really excited to announce that we have Lori Provin from the ISS National Lab joining us. She's the Director of Strategic Engagement and STEM Programs for the National Lab. And we will be kicking off today with a little bit of positioning and understanding of what is really happening on the ISS National Lab from a STEM perspective from Lori. So Lori, over to you. Really looking forward to hearing your comments.
Well, thanks, Cindy. It's good to see you again. And I want to thank Jose and Mauro for having me here. And Cindy, it's great to be with you all and to talk about things that are going on at the ISS National Lab. I'm also available for questions at any time, so please feel free. Some of you I may already know. I see a couple names I'm familiar with, so it'll be good to talk to everybody and meet some new folks. So as Cindy mentioned, I'm the Director of Strategic Engagement and STEM at the ISS National Lab. So in my role, I am one of the POCs to our implementation partners like the ICE Cubes folks that we have here. And then I also run the STEM programs. So it's a nice kind of combination. I get to meet the people that are providing the critical hardware so that we can do things in the interesting research we're doing on space station, as well as the STEM programs. So just by way of those of you who may not be familiar with the ISS National Lab, one of the reasons we're here to support this is that we are interested in supporting the work that you want to do and the research you want to do. And we have a series of constantly revolving proposals and call for proposals in everything from technology development to fundamental science that we do with NSF and NIH. We co-fund that. We have INSPA programs that we do, and we have STEM proposals that we have that are specifically pointed to STEM engagement, and that can be anything from K-12 or higher in workforce development. And of course, those of you who are maybe university related, you probably have students supporting your work, grad students or postdocs. And so we can try to help support that. Mainly what we try to do in our funding is, particularly the proposals that are not STEM, is really help fund our partners like ICE Cubes, so that that cost burden is taken off of you. And then you just have to worry about your own costs as the PI, but we have to do that with the IP. And then you can see we have those on our website, and I'm happy to send that out later or give it to Jose, and he can send it out post meeting here. And then our STEM proposal is a little bit different in that we fund programs that, like I mentioned, are more geared towards students directly. And the STEM proposals, the new STEM proposal for 2025 will be going out sometime probably late January, early February. So I encourage you, if you're not signed up to receive notification from the ISS National Lab, I encourage you to sign up, and then you can know when those calls go out for any of our proposals for research. So that's about it. I mean, that's kind of it in a very nutshell. But I want to just, again, invite you, if you have questions, please don't hesitate to reach out to me or Cindy, and Jose can always get a hold of me. So please feel free to reach out to one of them. And I'm excited. Thank you again for inviting me to be here.
No, thank you, Lori. All right. Well, thank you so much, Lori. And now what I'd like to do is introduce our keynote speaker, who is the ICE Cube Strategic Business Unit Manager. Mauro has been with ICE Cubes and Space Application Services for quite a while. So Mauro, over to you.
Okay, thank you very much, Cindy. Indeed, the goal of this presentation is to introduce, let's say, not only the MK2 version of the device, but the entire concept of Media Set that we have elaborated. Okay, very good. So this presentation will provide a very quick description of what the ICE Cube service, ICE Cube commercial service is, and goes presenting the various aspects of the media set concept and the way in which it can be usefully used on board the ISS. A few words about the ICE Cube service. So we are implementation partner of ISS National Lab, as you heard. We have, for the time being, one facility on board the ISS, specifically in the Columbus module. And this facility is able to host experiments, payloads that to which we provide power and data. The experiments can be accommodated inside the facility or outside, depending on the limitation in terms of needs, the needs in terms of power or dimensions. Our facility ensures the possibility of real-time connection to ground and from ground, and our system allows for real-time interaction by the user, by the PI, from his or her user home base. The payloads are internet payloads and can be controlled via standard internet protocols, actually. We cover the entire cycle of activities, from the first discussion with the PI and the possible support to the definition of the functional concept, to the definition of establishment of applicable requirements, to support to the engineering. And then if it is the case, we can provide test activity, or we can support the design or some part of the design or the entire payload. And then we take care of the logistic aspects for the launch and the return to and from the ISS. And of course, we take care of the operational aspect, in the sense that we prepare for operation, and depending on the willing and capability of the PI, we can leave to the PI the possibility to operate the payload from, I repeat, his home base, and the data are directly delivered to the PI. This is a schematic of conceptual steps of the end-to-end service that we provide, I already said. So the vision about the media set that we have developed is this one. We developed a very versatile system, easy to use in terms of utilization from the astronaut and utilization from the ground, from the user of the service. This system can operate through the entire ISS, at least the western part, because can be connected via Wi-Fi and communicate to ground via Wi-Fi. It can support several other payloads, because can be connected to several types of devices via USB, Bluetooth, or gigabit Ethernet. And in this sense allows for running special activity in orbit without having to equip the special payload or the device with complex or let's say mass consuming or power consuming characteristics or features. I will go later on in the details of this. Then the system can allow also for real-time communication with ground, and I repeat, with directly from the user home base. The peculiarity of this media set, in our view, is that it offers in one single device all these characteristics that in the past we realized were of interest for several payloads, but in many cases were not immediately accessible, or required some workaround solution that didn't bring to an optimal situation, request in some case wasting of crew time for basic activities like transferring data from one card which is in the device to a computer to download the data to ground and so on. In this case, all this scenario is vanishes, and we are in front of something which is immediately available and immediately connected to ground. So this is looks like nothing special. It's a box, and it can be considered a sort of a mobile computer in orbit, which has a possibility to let's say be connected to different devices. It offers a screen, microphone, speakers, and it can be used for, I repeat, supporting and control of experiment. It is interesting that inside this device there is a powerful NVIDIA Jetson Orin NX board, and which characterize this device as able for providing or running edge computing using artificial intelligence and machine learning, let's say, techniques. The customer, the PI, can upload to the system his own software. The software can run inside the system and can be used for multiple purposes. Can be used for analyzing the results or the data provided by a connected payload, and then can elaborate this data in real time, and can be used for closed loop control to the same payload, or the results, once elaborated, can be sent to ground to be elaborated on ground. There is the possibility of performing remote monitoring and predictive analysis of the behavior of some payloads, and it has also audio and video capabilities, and in this sense can be used for video conferences, for STEM and private calls. In the sense, we already have to say that with the first let's say, brick of this Media Set concept, we already had a number of real-time video conferences during the past Axiom missions, more than 80 events actually arranged in the video conference practically without any failure, any problem. And this allowed for setting up these video conferences with astronauts and worldwide distributed audience. The first step of the Media Set was not able to vehiculate video from ground to space. With this second model, with this MK2, we have this screen which allows the astronaut for receiving the video coming from ground. And the system can be also used for, I would say, private call, which can be relevant to health monitoring activities for the crew, or can be real private call in the sense that the astronaut talks with the family, for example. As an ancillary aspect of the hardware that you see there, there is the possibility of enhancement of the scene illumination on board the software, on board the station, using AI-based software technology, and there is the possibility of using this system all around the station, providing real-time link to ground. So this is the slide which describes the characteristics of the core of the system, which is this NVIDIA Jetson Orin. In addition to that, we have also 2 terabytes of onboard data storage media, which can be of interest for heavy, again, portable, but heavy AI-based applications. The system can be powered via a power bank, and in this sense, it can be used through the various modules of the International Space Station. Can be also powered via a power supply connected to the NASA inverter. Can be powered by the ICE Cube facility. So it is the powering concept is very versatile. Specifically for the activity, for the function of supporting other payloads, we provide 3 USB ports, 1 gigabit Ethernet port, Bluetooth connection, and we host the software of the customers for possible utilization on board. I already mentioned the real-time elaboration of data, the continuous access to the payloads in orbit. This allows, I repeat, can be a bridge for the PI to control in real time and continuously the payload, and the PI can access, can do everything from his or her user home base. Here is a slide which gives the idea of how the system can be connected to a multitude of different devices. You see here, many of them are related to health status monitoring, but in reality, we can connect, assuming that it is possible to connect the payload via Ethernet or Wi-Fi, or Ethernet or USB or Bluetooth. We can connect whatever type of payload and control it according to the capability of the payload itself. The system will remain in orbit permanently, and so for using that, it's just necessary to upload the software that we want to introduce in the Media Set MK2 and uploading the specific device that we need to upload. Important is that in many cases in the past, we saw that commercial or pseudo-commercial device had the problem of connection with the systems which are in orbit, and the problem of control from ground, problems of transfer of data. In this way, we have a system which is a permanent window on the ISS, window that can be opened from ground whenever you want. Another aspect of another possible scenario of the system is relevant to video conference with the ground. I repeat, actually more than 80 real-time events during the Axiom missions, also including real-time interview with the TV broadcaster, where let's say the video conference was transmitted, was broadcasted in real time. We have the possibility of having the improvement of the illumination of the scene via AI-based software. You see here an example of what can be possible with the software that we implement. On the top left side, you see an image of the astronaut in the normal, without any illumination conditions in cupola, and you see on the other quadrants the different level of improvement of the illumination. So this prevents or this avoids the need of establishing lights in the scene of where the video conference or the activity happens, and is specifically of help when we have something which an activity which moves through the various modules of the ISS. Another aspect that can be considered, until now we didn't do anything in this sense because the system has still to be launched, but there is the possibility to use this system for create monitoring and analysis, because if during a video conference with the medical staff on ground, the medical staff itself could augment or introduce in the call that they have with the astronaut, they could make use of some software, and there are many of them already developed and commercially available, of some software which takes the image or the video of the astronaut and provides some feedback from multiple points of view. And this data can be analyzed in real time or in space or on ground, and provide or a feedback to the astronaut, or complement the activity or the interview that is happening by the medical staff on board on ground, and can, let's say, complement in the sense that the artificial intelligence could also in real time advise the doctor on ground to move the interview or the discussion according to certain direction that can be realized as of interest by the system itself. In addition to this possibility of using artificial intelligence-based software in the interview with the astronauts, we have the possibility to connect this system to, let's say, wearable sensors, or to monitor via the media set whatever activity of the astronaut, and having in real time the elaboration of data. The type of elaboration depends on the interest of the PI, of course, but the system is powerful enough to allow for, I repeat, real-time elaboration of data and repeat, or feedback to the astronaut, or message back to the astronaut, or message to ground. So there are multiple type of activities and monitoring that can be implemented. Thanks to the screen that we implement, actually the astronaut had the possibility to interact also with the video from ground, and the system itself could be connected to, for example, this type of sensor or devices. In this way, also again allowing for real-time elaboration of data or transfer to ground. So this is more or less so this is in a fast ride what is the media set. In terms of time, we are going to launch it in SpaceX 32, which means April 2025, and the system will be permanently available on board. One aspect to consider is that the system will be available on demand, in the sense that it is not linked to whatever launch from ground. Or, of course, if you want to associate the utilization of the media set with another device, you have to wait for that device being in orbit. But if you want to use the system for whatever call with the astronaut, or whatever software activity in orbit, then the system is always available.
Thank you, Mauro. That was great. And what I'd like to ask you, just as you're continuing your points here, is specifically related to STEM. You know, we've talked about several applications, and you've mentioned them as you were going through your talk, in terms of live events or talks of students with crews, just the broad range of supportive educational activities, the competitions for coding using MK2, and then support of the media set for controlling and operating educational experiments developed by student teams. So do you want to just give a few concrete examples of those applications and some of the work? You know, you mentioned what's taken place, but in terms of STEM and education and students, you know, what have you seen that's worked well using the media set?
In the past, we realized that there is an interest for coding in space. Even the younger or youngest classes find an interest for coding, or at least there are indications that teaching artificial intelligence aspects to the young students can be of interest. And this system for sure contributes to inspire, in the sense that the coding can be done also on ground. There is not an impact of the microgravity on coding. That's true, but it's also true on the other side that all joining, for example, this the coding on this media set 2 with the presence of a camera. For example, we could I'm inventing now, but an activity of coding could consist of segmentation, which means recognition of the environment in the ISS. So the students could put together a code, or try to put together a code which is able to recognize some specific aspect that we indicate to them within a certain challenge. Or, for example, if you look at this image, at this slide, where you see the Media Set Mark II with on top what we call GoPro Hero 9 camera, which is actually the Media Set Mark I, which is already on board. I hope you can see my mouse. So the camera, the GoPro camera is connected to the Media Set Mark II in this case, and is the eye of the Media Set Mark II. But if you consider to put this camera in front of the screen, for example, we could think about say a STEM activity where on the screen you can send whatever image, whatever text you want, and the software developed by the student could consist of recognizing the image or recognizing the text which is appearing on the screen if the camera is looking at the screen. So you have actually two software running. One is the software which show the content in the screen, and the other software, which is the most important one, is the AI or ML based software for recognizing what appears on the screen. So in addition to this, we could also have a STEM activity for speech recognition where the astronaut is involved. For example, someone could elaborate or work around the software that is able to recognize the voice of the astronaut. In this case, of course, the astronaut becomes part of the activity, but this is the actual inspirational aspect. And for example, the astronaut could say something, and we could see if the software is good enough to recognize what the astronaut said, or just transcripting the text, or if there is, I don't know, something simpler like push one of the three buttons, the astronauts select one, and we see that the system recognizes that the button one has been pushed. So this type of activities, not neglecting the fact that you could have simple devices developed by students that could be easily connected to this device, to this media set, removing the need of whatever computer on board the station, removing the whatever need of complex interface. And in the end, the data are directly delivered to the school, and the students can operate in real time from their side, from their school or from their premises, the experiment, the activity.
Thank you. And Mauro, I think, given that we have folks here participating in this webinar that are very involved in STEM, I'd love to hear from them either through the chat, or if you want to raise your hand, we can unmute you. What is your experience with STEM education, and how could you see the media set augmenting what you're already doing in STEM education? So please, if you have a comment or a question, put it in the chat, raise your hand. We're very excited to have a little bit of a discussion. And while people are doing that, I want to ask you the question that we always get, Mauro, which is ICE Cubes an American company?
Let's say ICE Cubes is by itself a service, is a brand. It has been generated originally by Space Application Services, but now it is joined, managed, and operated by Space Application Services, which is an European company, and Aerospace Application North America, which is an American company based in Houston. So both the company has the same rights and the same, I would say, privilege for using the system according to an approach first in, first served. So we periodically see the list of the request for the utilization, and according to that, to define the plan for the utilization of the facility. For this device, it will be exactly the same approach.
Great. And we do have Anna Marie from AANA here. Anna is the payload integrator for Space Application Services North America. So Anna, do you want to just say hi and any comments from you based on what Mauro was just saying?
I just want to echo, I guess, kind of what Mauro said. I am doing the payload integration on the US side. So it is my job to help interface with, well, let me go back for a second. We have the unique opportunity because our facility is located in the Columbus module, but we launch here in the US from US, rockets. So we have the unique ability to be able to interface with both ESA and NASA. So it's my job to help kind of bring those two together, make sure that we're working hand in hand with both the team in Europe as well as people, our PIMS and our national lab representatives here in the US. To make sure that everything's flowing smoothly and we're meeting all requirements that we need to. So while we offer services in both Europe and here in the US, we have a dedicated team on each side to kind of make sure that we're ticking all the boxes that we need to. So if there's any kind of reservations about that, please be rest assured that we do have a team here in the US.
Does ICE Cubes currently work with the ISS National Lab?
Yes. One moment. Yes, indeed. We, as I said, our international partner, we developed one payload in 2022, actually, Getter Gatsby, in collaboration with the Florida University. And then we are now developing another payload for the Palo Alto Corporation in California. And this payload will fly in October 2025. So
Right.
the collaboration is actually, I repeat, the service, ICE Cube service operates worldwide. So we develop in collaboration with whatever customer wants to fly.
Good. And as we're talking, we are getting questions. So could you describe how and where astronauts live streaming using this fix the camera to one spot, or maybe switch to hand holding it to show something specific?
No, in the mobile version, which mobile version means when the camera is powered by the power bank, it is de facto a mobile device, so it can be used wherever in the ISS, assuming that there is the Wi-Fi connection, as it is the case of the ISS. So I want to say the camera, if you remember the picture of the Media Set Mark II with the camera on top, so the camera can be also rotated to the front in such a way that the astronaut can travel through the various modules and having the camera looking forward and having the screen of the Media Set looking at himself.
Great. All right, another question. I'm involved in STEM, and this one's from Dominic. I'm involved in STEM hackathons, so could imagine running an event where teams compete to come up with the best prototype application, and the winner might go on to implement it in space. How sophisticated would the developer's kit, or whatever the equivalent is called, be for people to develop a prototype, and how easily can people learn it, i.e., in a weekend if they were doing a hackathon?
But let's say the system can be, we were thinking about what we can call a science reference model, or better, a simplified model that can be used for developing whatever protocol or whatever software. And it is basically composed of the developer kit of NVIDIA containing the computer board, and then there is a screen, and that is that simulates the Media Set Mark II sufficiently to the level for a developer for developing his device and to see what is the effect on the effect, what are the results on this system. Then this NVIDIA developer kit, which contains the computer board, has also USB ports and other ports, and then can be used to connect the specific device that the students are interested in developing or in launching. So I want to say that the system can be put together quite easily. We can also offer this what I'm describing now. I don't have an image. I didn't prepare an image now. It's not the case to waste time behind that. But I repeat, we elaborated a concept of a system that we can also ship to an organization or to whatever institute are interested to elaborate, or company are interested in elaborating the software on ground before, of course, uploading the software to space.
Okay, great. How much power does it take when running the camera is another question.
Or let's say the system during a video conference where there is the complete audio video from to space, the power consumption is about 18-20 watts.
Great.
You have to
And
consider the screen is 10 watts and the NVIDIA board typically arrive to, for example, can arrive stressing the CPU and the GPU can arrive to 15-20 watts. 20 watts.
Okay, great. And you mentioned we also get a lot of questions on cadence and availability. And you mentioned as you were talking, in terms of availability, it appears that the cadence is continuous and not dependent on launch once it is launched. Is that correct?
It is correct. Let's say the main dependence is on the crew time, so on the availability of the astronaut for doing whatever activities needs to be done with this device. It can be simply installation and powering, and then the astronaut do something else, or can be a more time demanding activity because the astronaut has to interact with the system, for example, during a video conference or for doing whatever other activity. But the best way to think about, to approach this device is thinking about that as a ground device, no? In the sense not to be intimidated by the fact that it is in space. It can be operated in space as it is can be operated on your desk. So start from this vision and think how to use it.
Perfect. And I think we're coming to the end of our questions here. The big question is, are you commercially selling this, and what does the pricing look like for the Media Set?
This strongly depends on the type of activity that you want to do. I mentioned video conferences, and let's say the video conferences are done with the astronauts. So first of all, we need the authorization from ISS National Lab for having this video conference and for engaging the astronaut in that. But let's say from our point of view, in terms of in this case implementation partner, the cost can range between, let's say, $15,000 to $20,000 for an event of, for example, 30 minutes. Okay, but this is just indicative in the sense I'm mentioning the numbers for one single event, but maybe with I'm maybe going too much far, but we could think about a frame agreement which considers or includes 20 or 30 or whatever other number events per year with ISS National Lab, and then the cost will be revised according to the characteristic of this frame agreement. Or if there is the need, or the system can be used for monitoring some activity of some experiment which is running on board the station. This is possible, of course, thanks to the camera, to the artificial intelligence which is inside. So we could have the system connected to the the device, but we could also consider to monitor the motion of some, let's say, free flyer on board the station, and the artificial intelligence which is in our system can monitor the trajectory, can derive parameters about the movement and so on. So can derive data which are of interest for the API. So in case there is this activity of monitoring some device on board, of course, there is so the range is more or less the same. Can be a little bit, let's say, in the range of 13 to 17,000, something like that. Or there is an activity of, I repeat, coding, where the astronaut is not involved, so the system can be simply installed in a position on board the station, powered, and then runs, controlled from ground, of course, in interaction with the device or without interaction with the device. So in this case, the cost depends on the length of the mission. But again, we are starting from something which is in the range of 20,000 plus the implementation of the mission of the specific device that shall be launched. So this is something different and depends on the characteristic of the device to be launched. But per se, the utilization of this camera, especially if we reach a sort of let's say intensive utilization and continuous covering the various type of utilization, I repeat, in our opinion, the cost is not so demanding, is not prohibitive.
Good. Well, I think that came across, and I think based on your prior remarks, I think it looks like you are willing to work with folks to understand what the best pricing could be for the different types of activities, whether it's one or multiple types of activities. So I think that came across loud and clear. All right, well, Maura, we are out of time, and I really appreciate everybody joining us. We will send the PowerPoint out as well as answers to questions to everybody by next week. And we really want to thank Lori Proven for joining us from the ISS National Lab. Looks like really exciting things continuing to happen with the ISS National Lab. So we'll stay tuned, Lori, and be looking for these NLRAs and other exciting activities that you have planned. And we're all looking forward to Seattle.
But we'll get out again, if you're signed up for announcements, you'll know that this is a really interesting opportunity here at ICE Cubes. And I can tell you that the team is very customer oriented, and they will help you. If you bring them your idea, get creative with them, and they will help you bring it to fruition. So we look forward to you bringing in some ideas using this technology.
Awesome. Thank you so much, Lori. Thank you, Mauro. Thank you, Anna. And thanks to all of you for joining us today. And happy Thanksgiving to everyone. And we'll be in touch soon.